Hello everyone. This video is on the Knewton Alta assignment for section 6.1 part 1 called Evaluate and Write Exponential Functions. So in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, right? The structure is the same, so I'm hoping that watching me do these here will help you in some way when you work on the assignment on your own. Alright, so on your assignment page you should have the title, the mastery bar telling you how far along you've gotten. You should be able to see the objectives. It looks like there are 3 objectives for this assignment. Under the current objective, there should be a question related to that objective. And on the bottom of every question, there should be a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. Alright, this is for instructors only. But you will have a more instruction button. Alright, this is if you're struggling with a topic or a question. Click on this and you'll be taken to a page with further reading or videos to study, and then you'll have questions related to that instruction. And if you complete those questions correctly, you'll make progress through the assignment. Alright, so the first objective I'm looking at is identify exponential functions. Alright, so before I get into going through this part of this question here, let me talk about how they're defining what you're going to see if you click on more instruction, how they're defining exponential functions. Alright, so an exponential function there's an n there, sorry, that's an n. An exponential function. It's any function that can take the form f of x or y equals a times and then b to the x power. So the reason it's called exponential is because the variable, the input variable, is going to be in an exponent. Now there are some special things about this. This is going to be a non-zero number, right? Because if it were 0, then it would be very uninteresting. It would just be y equals 0. So this a, sometimes referred to as the initial value, is non-zero. And b, that's called the base on the exponent of x here, must be positive. B has to be a real number greater than 0. Because if b is negative, some bad stuff can happen. Alright, and the domain won't be all real numbers. And then some special things about this. The domain is going to be all real numbers. You can plug in any value for x that you wish. Now, if a is a positive number, right, if this lead coefficient here is positive, then the range of a function that looks like this is all positive numbers, right, from 0 to infinity, but not 0 itself, and it would look like this. Or like this. It could be like this or like this. And this is called exponential growth. This first one I wrote goes up from left to right. This one's called exponential decay. It goes down from left to right. but still the range is only positive numbers. Now, if a is negative, then it just flips these over. Then the range will be all negative numbers. So from negative infinity to 0, but not 0 itself. So just flip these over, like flip these over the x-axis here. So like this, or like this. But not actually touching the x-axis. The x-axis is actually a horizontal asymptote for all these basic exponential function graphs. So a lot of stuff here. Y equals 0 will be the horizontal asymptote, the x-axis. One other thing is that these cases here are if the base is bigger than 1, and then these cases here are if the base is between 0 and 1. Right. So lots of stuff. Okay, basically though, can we get it to look like this? Can you get your function to be, f of x equals y equals some number times a positive number to the x power, right? And to the x power only, right? Can we write it this way? If so, we have an exponential function. If not, we don't. Right. Okay. So back in the, well, I'll just write out they're asking us here in the question, which of the following are exponential functions? Select all correct answers. So there might be more than one. So you see here f of x equals 8 times 14 to the x power. That's a times b to the x, where a is not 0. It's 8. And then the base, that base on that power of x, is positive. That satisfies the definition that I just wrote up for you. So this is an exponential function. And if you want, you can graph it. Look at the graph of this. It'll have a domain of all real numbers, a range of all positive numbers, since a is positive 8 there, and since the base b is bigger than 1, it's going to be an increasing function. And I'll show you that. All right, let's go. This is that desmos.com free online graphing calculator. F of x equals 8 times 14 to the x power, and you see this as you go from left to right, the value of the function is definitely increasing. I would call this exponential growth. I know it looks like it touches the x-axis, but it actually doesn't. If you zoom in close enough, you'll see the graph is not touching the x-axis. And it's actually a little bit above over here, and it'll stay above. It'll always have a positive output. So the x-axis is actually a horizontal asymptote. The graph approaches the x-axis, approaches the line y equals 0. Only as you move to the left, though. As you move to the right, the graph goes to infinity, right? The output goes to infinity. All right. So that's one. How about this? G of x. Again, it doesn't have to be f of x. It can be g of x, h of x, k of x, whatever. Equals 13 times 1.97 to the x. Well, let's see. That's a number a that's not 0 times b to the x, where b is positive. This is an example of an exponential function. And again, I'll leave that to you. You can look at the graphs of these on Desmos on your own if you wish. Here, h of x equals 12, some number a, times b to the x, where b is positive, which is 1/8 to the x. Now this kind of a function, again, the a is positive, so the range is going to be all positive numbers. The graph's going to be above the x-axis. But you see the base, that b to the x, the base b is less than 1. So this kind of function is going to have what they call exponential decay, or it's going to be decreasing as you go from left to right. So I'll show you that one. All right, I'll show you that one. So it was 12 times 1/8 to the x. Right? And do you see the decay? See the decreasing function here? Again, the x-axis is not being touched. It looks like it, but if you zoom in close enough, it's not touching the x-axis. The range is only positive numbers here, from 0 up, but not including 0. And we have a decreasing function. And again, that's when it's b to the x, where b is less than 1. But it is exponential. It has all the same properties of all the exponential functions I defined on that page. Now, these last two are not because of the base. Yeah, you got this number out front, 5 and 11, a times something to the x, but that b is negative. And bad things happen. It doesn't have a domain of all real numbers like our definition of an exponential function should if the base is negative. And let me show you what happens when the base is negative. I'll put this example up here. 5 times negative 1/3 to the x. So 5 times, well, even just negative 1/8, right, or negative 1/3 to the x power. And you see what happens. It bounces back and forth from being positive to negative and stuff, and there are some, it's not continuous, it's not a nice smooth graph. There's a bunch of holes in it because this is not going to be a real number. It's not going to be defined, have a real number output if the power is any fraction with an even denominator. Right? Because if I say I replaced x with a half, that'd be the square root of negative 1/3. That's imaginary. You're not going to see that on this graph. These are real number lines. All right, so that's why we are not going to consider a function like this an exponential function. Yes, there's a variable in the exponent, but by our definition, because the base is negative, we're not going to consider it. And the same thing for this k of x here, 11 times negative 15 to the x. So the only three that satisfy the definition, a times b to the x, where b is positive, are the first three. Right. And then after you submit an answer, you're going to be told if you're right or wrong, and then be given some sort of answer explanation. Right. Please read through the answer explanations just to make sure that you understand why something was incorrect or incorrect, and hopefully you can learn from your mistakes. And I guess one thing I should point out also is that the base can't be 1 either. Probably should have added that on. Notice I had base bigger than 1, base between 0 and 1, but not equal to 1. Because if the base is 1, right, 1 to any power, it's just going to be 1 again. So then you'd have a graph of a horizontal line, and the range wouldn't be all positives or all negatives like they should be for an exponential function. So yeah, so if the base is 1, just like if a were 0, something uninteresting would happen. Right, so we don't want those. Right? All right, so continuing on. All right, now I'm just into the objective evaluate exponential functions. So this is just simply, just like you evaluate any function. You're given a rule for a function and plugging in some input, getting some output. What is that output? Right. So I'll write this up. So they're giving us an exponential function here. Now it doesn't look like, remember I said this is how an exponential function can look. Any function that can be written this way is exponential. They're giving us f of x equals 3 to the x minus 3 power, right? X minus 3 is all in the exponent. And you might be saying to yourself, hey, that doesn't look like this, because this has just the base to the x power. Well, yeah, sure, I see that. But this can be written that way. And if it can be written that way, it's exponential. And let me show you how. It's through properties of exponents. Right? Now I'm going to assume you know some properties of exponents from a basic arithmetic class or something. Up here in the power, this exponent, when do you subtract exponents? you subtract powers when you do division. So this 3 to the x minus 3 is the same thing as 3 to the x divided by 3 to the 3. And 3 to the third power is 27. So this is 1/27 times 3 to the x. And there's how this function looks like that form. Right? A would be 1/27, and b is 3, and then you have to the just the x power. But so although functions may not look like this form, they if they're exponential, they can be written in this form. Right? But that's neither here nor there. All we're asked to do is find the value of f of 1. So again, you should know how functions work, right? This is just I plug in 1 for x and see what the output is. So this would be 3 to the 1 minus 3 power. Now 1 minus 3 is negative 2. And I hope you remember how negative powers work. The negative powers are just the reciprocals of the positive ones. So 3 to the negative 2 is just 1 over 3 to the positive 2, which is 1/9, right? 3 squared is 9. There's the output that they're asking for, right? And if you were to graph this function, the ordered pair 1, 1/9 would be on the graph. But all they want is that 1/9, right? F of 1 equals 1/9. Great. All right. Next question. All right, and then the third objective, the only one we haven't seen yet, find the equation of an exponential function given the initial value and a point. Now I did tell you, I said it out loud, I didn't write it, but in the definition of an exponential function, again here, this value a is called sometimes the initial value. Right, that means the point 0, a would be on the graph. Because remember, anything that's not 0, like b, whatever b is, anything that's not 0 to the 0 power would be 1. So then you'd get 1 times a, or a, for the output when x is 0. So they're calling a that initial value, right, when x is 0. Or the y-intercept. Right, same thing. Now, in order to write an equation for an exponential function, notice that there are two unknowns here. I need to just know what a is, and I need to know what b is. So I just need two ordered pairs. I only need 2 points to find these two unknowns. It's just like when you had a linear equation, y equals mx plus b, right? You just needed to find m and b, and you only needed 2 points for that too, right? If there are only two unknowns, I only need to use 2 points. Okay. So here, the graph of an exponential function has a y-intercept of 9, and that's that initial value. 0, 9, 0, a. So a is 9, and it contains the point 2, 144. Construct the function that describes this graph. All right. So again, I know what the equation, I know what a function that's exponential should look like. And we're told, the y-intercept is 9, or the point 0, 9, right? So a equals 9. That's that initial value. So the function looks like this then, f of x equals 9 times b to the x. Now I just need to find b. And that's where the other point comes in. They said the point 2, 144 is on the graph of this function. Right? So, when I replace x with 2, f of 2, f of x, f of 2 is 144. So I substitute these into my equation over here and we'll solve for b. So f of 2 is 144, so the left side becomes 144 equals 9 times b to the second power. X is 2. I replace x with 2. Solve for b. Dividing by 9, we get 16 equals b squared. And then b can either be positive 4, taking the square root or whatever, or negative 4. But remember this here, right? When I write an exponential function in this form, the base must be positive, so I can't use this negative one. It must be 4. So I'm popping that in, and a is 9. We get our function. F of x is equal to 9 times 4 to the x power. And this is our exponential function that satisfies what they said. When x is 0, the output would be 9. And when x is 2, you'd get 9 times 16. The output would be 144. Perfect. And that's what I'll type in. Now they already have the f of x equals, right? So I'm just typing the rest of it. 9 and then in parentheses 4 to the x power. 9 times 4 to the x. Great. But yeah, you only need information about 2 points to be able to find the equation of an exponential function. All right. Next. All right, so sticking with the same objective, here we have an exponential function in the form y equals 500. So 500 is that initial value, that a times b to the x, contains the points 0, 500, which we already knew. Right? If x was 0, y would have to be 500. And 3, 4. What is the value of b? Now we're only asked to find the value of b, right? We are not asked to write the function, just the value of b. And that's where that 0.34 comes in. So very similar to the last example. Right, I know that y equals 500 times b to the x power. And the 0.34 is on the graph, they told us. Right? So I replace, x with 3 and y with 4 and solve for b. So 4 for y on the left side equals 500 times b to the third power, right? Replacing x with 3. Then I divide by 500. That would give me 1 over 125 equals b cubed. And then take the cube root of both sides, right? So b would be 1/5. And that's all they want. What's the value of that base if the 0.34 is on that graph? The value is 1/5 or 0.2. And notice they're telling us don't write b equals, just write the number. What would be b? 1/5. Again, or 0.2. Whatever you write, as long as it's equivalent to the correct answer, it should be good. Excellent. All right, next. All right, so now we're back to just simply identifying those exponential functions, right? Which of these can take this form? All right, once again, which of the functions have all this happening? can take this form. Now, again, if it doesn't look like this, and you can still write it like this with some properties, it's an exponential function, like that 3 to the x minus 3 earlier in the video. All right, so this is 8 times 1/8 to the x. The base is positive. That's good. Here, the negative 5.31 to the x. The base is not positive, so that's not good. I'm not going to. I mean, yes, there is a variable in the exponent. I get it, but the base is not positive, and that's a problem. All right, you saw that with that one graph earlier with the base of negative 1/3. Here, 2 times 5 to the x, positive base, good. 6 times 4.87 to the x, positive base to the x, that's excellent. And then here another one with a negative base, so not considered exponential by definition. Great. All right, next. So those should be pretty simple. Same thing for these. I mean, now notice it's exponential. You have 5 to the x, but then there's this plus 12 after. All that does, and I hope you remember your function transformations. All adding 12 is going to do is take the graph of this 5 to the x and move it up 12 units. Right? Adding a number or subtracting a number, all that does is take our exponential graph and move it up and down. All right, so it's still considered exponential in a sense. It's just transformed, just moved up or down 12, up here, up 12 units. All right, so this one I'm just going to say out loud. This one's a joke. What's f of 0? Well, that'd be 5 to the 0, which is 1. Remember, any non-zero number to the 0 power is 1, plus 12. The output would be 13. Very simple, that one. All right, next, another evaluation. And again, a very easy one, in my opinion. If I replace x with 0, the exponent here becomes 3 times 0, which is 0. 2 to the 0 power is 1. Then times negative 8 would be negative 8, plus 3 would be negative 5. This function would have an output of negative 5 when the input is 0. Okay, and one more evaluation. All right. So this one I'll actually write out because the power is not going to be 0 this time. All right, and again, the function we're given here, f of x equals 4 times 1/4 to the x plus 2 power. Again, I mean, I know it doesn't look like this form, but it can be written that way. If I write this as 4 times and then 1/4 to the second times 1/4 to the x, right? Because remember, when you multiply things with the same base, you add the powers. So the power on that would be x plus 2. And 1/4 squared is 1/16, but times 4 would be 1/4 again. So you'd have 1/4 times 1/4 to the x, and there you go. There's your a is 1/4, b is 1/4, and to the x power. I'm just saying. Again, you don't have to do all this. You do not have to do this. I'm just saying that some functions don't look like they're in that form, but can be written in that form. We're just asked to find f of 1, right? If I input 1, what's the output? So that'd be 1/16. I hope you can see from here. It'd just be a 4th times a 4th. All right, but let's go through this. This would be 4 times, 1/4 to the 3rd power, right? 1 plus 2. So 4 times, 1/4 to the 3rd power would be 1/64. And then 4 over 64 is 1/16. And there's your output, totally simplified. 1/16. And it did say answer in fraction form, right? So don't write that as a decimal. Okay. Next question. So that objective's done on evaluating. That should be a pretty simple one. So should the identifying. Identify which of these are exponential. All right, so 16 times x to the 10th. This is a polynomial function, right? In an exponential function, you have a numerical base and a variable exponent, a variable power. Right? In power functions or polynomial functions, you had a variable base and a numerical power, right? Here you have number base, variable power. Here you have variable base, number power. So that's not exponential. Same thing with this one, 10x to the 9th. That's a polynomial again. This is exponential. 6 times a to the x, the base is positive. This is exponential. 8 times 1/9 to the x, the base is positive. And then again, I have a polynomial at the end, x to the 8th, right? That's another polynomial term here. So there's only just the two exponential functions this time. All right, great. And that should be it. I should probably have one more of those. Yeah, just one more of those. So again, just identify which of these are, by definition, an exponential function. Here we have a exponential thing going on, but the base is negative. So that doesn't satisfy our definition. Same thing here. Negative 10 to the x. Here it's a positive number to the x times some 13 there. That's exponential. Positive 1/7 to the x times 13. That's exponential. Positive 12 to the x and then times 10. That's exponential. So 3 exponential functions here. Great. All right. So the identifying and the evaluating should be relatively simple. All right. So the hardest part probably the finding the equation. All right. What's the value of A? What's the value of B? So that the two ordered pairs, the 2 points on the graph that are actually on the satisfy the function, satisfy the equation. So construct an exponential function that contains the points 0, -5. So there's the y-intercept, right? X is 0, so that -5 is the initial value. It's the value of A. And 4, -80, and we'll use this 4, -80 to find the value of B, to find that base. So again, we know what they look like, and the point 0, -5 is on this, so there's the value of A. Right? A equals -5. We know now the function looks like this. F of x equals -5 times b to the x power. Now we use the other point that we were given. 4, -80 is also on the graph. I replace x with 4, and then f of 4 is -80. I replace f with -80. So -80 on the left equals -5 times b to the 4th power. All right, replacing x with 4. Dividing both sides by -5 gives me 16 over here. B to the 4th. So b could be 2 or -2. Right, 2 to the 4th is 16. -2 to the 4th is also 16. But remember the base in our definition of an exponential function, the base must be positive, so can't use the -2 base. So popping that in, we get our function that has these 2 points on it. Our exponential function with these 2 points is f of x equals -5 times 2 to the x. And that should be good. All right. And you can look at a graph of it if you wish and make sure those points are on it. All right, so -5 and then in parentheses, the base 2 to the x power. Wonderful. So there's one more of these, and that should be it for this preview version of this assignment. Alright, so there's another one where they're telling you the value of a, right, y equals 64 times b to the x. That initial value is 64, 0, 64 is on the graph. So we're going to use the 0.31 to find the value of b. So I can see right now that b would have to be 1/4. But let's write it out. Alright, so we have y equals 64 times b to the x. Right? The 0.31 is on the graph. So when x is 3, y is 1. So I put that in. 1 on the left equals 64 times b to the third on the right. Divide by 64, we have b cubed equals 1/64. And then take the cube root of both sides, b equals positive 1/4. And it should have been positive. Right? You know, remember, for our definition of an exponential function, the base is positive. But that's all we're asked to enter, though, is the value of b, right? Not the entire function. So just 1/4. Right? I'll write it as a fraction. It doesn't say don't put a decimal, so I guess you could put 0.25 if you wanted, as long as it's equivalent to 1/4. And that should be it for this preview version of this assignment. So as I said at the top of the video, please understand that the questions I saw here, may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, right? And the structure is the same. So I'm hoping that watching me go through these examples here help you in some way when you work on the assignment yourself. And thank you very much for watching.